Welcome to this explainer. Today, we're diving straight into a seriously fascinating and highly debated framework for Earth's history, the young Earth creationist model of a global catastrophic flood. We're going to look at how this specific worldview interprets the rocks beneath our feet, the fossils in the ground, and the histories passed down across cultures. It's an exploration of a model that challenges mainstream assumptions and offers a completely different lens for understanding our planet's past.
Okay, here's our roadmap for today. We'll be hitting 5 key areas: the global flood hypothesis, gradual change versus catastrophe, decoding the fossil record, a post-flood ice age, and finally, the logistics of the ark. Let's get right into it.
Part 1. The global flood hypothesis: myths, memories, and water. The source material kicks things off by establishing the baseline debate about our origins, and then it looks closely at human historical memory.
So this framework suggests that when we look at the world, observers basically fall into one of two camps. You've got a design model, which argues the universe and life were created with intention, or a nature model, proposing that time, chance, and physical processes alone produced everything. The really wild part here? Both camps are looking at the exact same scientific data. The same rocks, the same fossils, the same oceans, but they interpret that data entirely differently based on their starting assumptions. What's truly fascinating to think about is the sheer volume of geographically separated cultures that share a remarkably similar memory. We aren't just talking about the biblical account in Genesis here. We're looking at the Epic of Gilgamesh in Mesopotamia, ancient Celtic traditions, Greek histories, Chinese characters, and pre-missionary African cultures. Across the globe, there's this shared tradition of a catastrophic, water-based judgment survived by a tiny group of people and animals. The model asks a pretty compelling question. Do these stories just spontaneously generate worldwide, or do they point back to a shared human memory of a real historical event?
To really wrap our heads around the scale of the geological claims we're dealing with, consider the number 321 million. That's how many cubic miles of water are currently sitting in our planet's oceans. To put that in perspective, that's enough water to cover a perfectly smooth Earth nearly 2 miles deep. According to the biblical narrative, this water didn't just fall as rain, it erupted from the fountains of the great deep. Modern geology actually acknowledges that vast reservoirs of water are locked deep within the Earth's crust and mantle. The flood model proposes that a massive geological upheaval released the subterranean water alongside atmospheric rain, radically transforming the planet's surface.
Moving right along to Section 2. Gradual change versus catastrophe. Reading the rocks. Let's explore how geologists have historically interpreted the massive rock formations that literally shape our planet.
For over a century now, the mainstream lens has been something called uniformitarianism. Basically, it's the assumption that the slow processes we see happening today, like gradual erosion and slow sedimentation, are totally sufficient to explain how Earth's features formed. It's famously summarized as, "The present is the key to the past." If a river cuts a millimeter of rock a year today, uniformitarianism assumes it always did so, meaning deep canyons must have taken millions of years to form. But the global flood model pushes back on that assumption directly.
To show how a catastrophe can actually mimic millions of years of slow erosion, the source points us to J. Harlan Bretz's discovery in Washington's channeled scablands. For years, geologists thought these massive dry waterfalls and deep channels were formed slowly over time, but Bretz's research concluded they were carved rapidly by a massive sudden flood following the collapse of a glacial ice dam. For supporters of the global flood model, this shows that massive geological features don't always require millions of years. Sometimes, they just require a whole lot of water moving very, very quickly.
And the timeline of Mount St. Helens perfectly illustrates this point for advocates of catastrophism. After that violent eruption in 1980, multiple distinct layers of sedimentary rock were deposited in mere days. Just a few years later, subsequent mud flows and rainfall carved out a 14-foot-deep Little Grand Canyon. To them, this modern observed event proves that vast amounts of time aren't strictly required to create heavily stratified rock layers or deep canyon systems. It can happen in a flash.
The source also highlights a huge geological anomaly: perfectly bent and folded rock layers found deep within the Earth's crust. Think about it. If those sedimentary layers took millions of years to slowly deposit and harden into solid rock, applying immense pressure to them later on should just cause them to fracture and break. But since they're smoothly folded, this model suggests they were buckled by immense tectonic pressure during a rapid, global catastrophe back when the mud and sediment were still soft and wet.
All right, let's pivot to Section 3, decoding the fossil record, sudden appearances.
Time to see how this framework interprets the biological evidence, namely the billions of fossils buried beneath our feet.
So, a super crucial point to understand here is that fossilization is actually incredibly rare under normal conditions. When an animal dies today, say a squirrel out in the woods, it doesn't just become a fossil, it decays or gets eaten by scavengers. To get a perfectly preserved fossil, the organism requires rapid catastrophic burial under heavy sediment like mud or ash to protect it from oxygen and scavengers. The fact that we find billions of fossils packed into massive continent-spanning sedimentary rock layers suggests to supporters of this model that large-scale rapid water events had to bury these organisms suddenly.
This leads us right into another intriguing puzzle, known as the Cambrian Explosion. Deep in the geologic column, dozens of highly complex animal groups just suddenly appear in the Cambrian rock layers. Take the trilobite, for instance. It's an organism with fully developed, highly complex eyes, and it appears seemingly out of nowhere, without a clear trail of simpler ancestors leading up to it. The flood model interprets this not as some evolutionary leap over eons, but as the sudden, catastrophic burial of a complex marine ecosystem that already existed.
To back this perspective up, the explainer leans on observations from secular scientists. Take this quote from the late Harvard evolutionary biologist Stephen Jay Gould, where he acknowledges the extreme rarity of transitional forms. While the evolutionary tree of life shows smooth branches connecting different species, this framework argues that those branches are really just theoretical inferences. The actual physical fossil record is heavily disjointed. It shows species appearing fully formed and remaining stable, a pattern that advocates say aligns perfectly with the model of sudden, catastrophic burial of distinct animal kinds. Now, let's jump into Section 4, a post-flood ice age, a catastrophic climate mechanism. Here is where the global flood model attempts to solve a major climatic mystery. What actually triggers an ice age?
Mainstream science often struggles to pinpoint the exact mechanism that kicks off an ice age because you need two seemingly contradictory things happening at the very same time: massive precipitation and freezing summers. Let's look at how this model builds a catastrophic climate engine. Step 1. Massive volcanic activity during the flood severely heats the oceans. Step 2. That same volcanic ash blocks sunlight, plunging the continents into a deep freeze. Step 3. The warm oceans cause massive continuous evaporation, which then falls over the freezing continents as relentless extreme snowfall.
So rather than an ice age dragging on for tens of thousands of years with highly debated starting mechanisms, this framework argues it was a much more severe but highly accelerated climate reaction. They view the ice age as a rapid, temporary phase that directly and naturally followed the extreme heat and atmospheric disruption of a global tectonic flood.
Finally, we reach Section 5, the logistics of the Ark, feasibility of the vessel. We really have to look at the practical reality of the survival vessel detailed in the source material, Noah's Ark. Could it actually work?
According to the dimensions laid out in Genesis, the Ark was roughly 450 feet long, 75 feet wide, and 45 feet high. What's super interesting about these dimensions is that they aren't the proportions of some tiny, cartoonish houseboat. They're actually remarkably similar to the engineering ratios used in modern heavy-sea cargo ships, ships designed specifically to remain stable in violent oceanic conditions.
With its 3 decks, the source emphasizes the massive scale of this vessel by calculating its internal volume at 1.5 million cubic feet. To help visualize that massive space, try picturing the capacity of more than 500 modern railroad livestock cars. It was an absolute behemoth of a structure.
But here is the big question. How did all the animals fit on board? Well, the framework explains this by distinguishing between our modern classification of species and the biblical classification of ancestral kinds. You see, a kind is a broader biological category with massive built-in genetic diversity. For instance, Noah didn't need to bring a wolf, a fox, a coyote, and a toy poodle. He only needed 2 representatives of the ancestral canine kind, from which all modern specific canine species later descended. Using this biological classification, creation researchers estimate that a maximum of only about 16,000 individual animals were needed on the Ark to preserve all the genetic diversity we see in land animals today. When you run the numbers this way, given that 1.5 million cubic feet of space we just talked about, 16,000 animals would leave plenty of room left over for humans, supplies, and food for the journey. The seemingly impossible logistics start to paint a very different picture for these researchers.
Interestingly enough, the source also connects the biblical narrative of human repopulation with modern genetic observations. The flood story claims the entire modern human race repopulated from a single surviving family.
Today, population geneticists study what are called population bottlenecks, evidence right in your own DNA that human populations dropped sharply and severely in the past, heavily reducing genetic diversity before expanding again. This model views those genetic bottlenecks as the direct observable signature of the global flood survival narrative.
As we wrap up this explainer, we're left to ponder a really central question. Both the nature model and the design model are looking at the exact same world. We're talking about the same rocks, the same fossils, and the same climate clues beneath our feet. Does this evidence point to slow, uniform change over millions of years? Or are we literally walking on the dramatic scars of a rapid global catastrophe? It's a profound question about our origins, and how you answer it completely shifts how you view the history of our planet.